So I heard a mathematician, a renowned mathematician, once say that you can find absolute truth only in mathematics or religion. This is a common belief among mathematicians, and to some extent reflected in the works of Korzybski and his own fascination with mathematics and the mathematical approach to some of these important questions. The statement, however, has a caveat. The absolute nature of mathematics is valid but limited to the domain of mathematics. Whether a universe is rational and if mathematics can be applied to any aspect of the perceived universe is an important question, but without a simple answer. The Nobel laureate Eugene Wigner, a physicist, in 1958 wrote this beautiful essay. It's really worth reading. It's called The Unreasonable Effectiveness of Mathematics in the Natural Sciences, which really captures the sentiment. So the theme of my presentation is really about language and reality, but I'd like to take a physics or a mathematical perspective on this topic. And I'll apologize multiple times during this talk for the oversimplification of some of these ideas. I simply hope to make a simple point here. Right? I'll move to something Corey touched upon yesterday. In 2015, there was this Twitter storm, Dressgate controversy of on Twitter about the color of this particular dress that people were seeing. Some people saw this as blue, black, or white, yellow to golden. It's very interesting to note that even such a simple and harmless question about the color of a dress brought people together. Cognitive scientists and philosophers and the lay public came together to discuss deep issues about cognitive science and the nature of reality. It's also very amusing that after this event, there's hundreds of papers or tens of papers have been published on this subject. And there's actually a whole issue, special issue in the Journal of Vision that's been devoted to the Dressgate. But I want to delve into something a little simpler, right? So a deeper question, and which is more relevant to me as a physicist. I want to investigate color. And so I ask the question, what is the color of this object, the apple? Presumably we're all seeing the same thing. Well, then that leads to another fundamental question, what is color in the first place, right? So the modern epistemology of color is based on a Newtonian version of optics and vision, right? It's modern, it's post-Aristotelian, but this version of color that Newton presented is very popular and it's brilliant. But it has left scientists wanting a little bit more. So more needs to be said about this. Newton says that light is composed of various wavelengths, and each wavelength is composed of, refers to a different color. And the reflection of a wavelength from the object results in the apparent color that we attribute to the object. Now, the dictionary definition of color is the property possessed by an object of producing different sensations in the eye as a result of the way the object reflects or emits light. Now, there's an apparent contradiction in the terms possessed by an object and sensations in the eye. One refers to the sort of extensional meaning of the term color, the other to the intentional meaning, right? And strangely, we attribute color to an object on the basis of what it rejects and not what the object keeps, right? So certainly in this example of color, maxims like in the eye of the beholder or map is not the territory are true in a literal sense. Now, the question of reality has been investigated widely for a long time. In Western philosophy of Plato, Goethe, Kant, Schopenhauer, Hume, Wittgenstein, among others. The Eastern Vedantic philosophy, there's physicists like Heisenberg and Eddington, Thomas Kuhn, and cognitive scientists who discuss interesting cognitive states like synesthesia or schizophrenia extensively talk about various aspects of this question and present their own versions, often contradictory viewpoints. Right? Now, I don't want to go into details of these theories, but I simply want to mention a couple of things. So a popular notion of reality that emerges in the Vedic cultures of ancient India maintains that the world is a mere illusion, right? Referred to as Maya. Now, there's a Shankarite school of Vedantic tradition, which has gone to the extent of even denying that a universe exists. Their claim is that a universe is a simple dream, and with the creator being the dreamer. There's a school of perspectivism, which argues that reality has no absolute character, but depends intimately upon the nature and viewpoint of the observer. A school of conceptual reality claims that we have no direct access to reality except through the concepts we create to comprehend the world, like David Hume said. Thomas Kuhn argued that scientific theories have a natural subjective character, since by their very nature, they're simply exposed to the predispositions of the authors of these theories. The physicist Heisenberg divides scientists as falling into three categories when it comes to this question. So there's a metaphysical realists who claim that the world and essentially everything that we perceive is indeed real. There are the dogmatic realists who are of the view that everything in the world can be objectified, whether it's real or not. Okay. And their claim is that the laws of physics can explain everything that falls within the realms of our sensory world. And then there are the practical realists, or the least conservative of all, who claim that most of our experiences can be objectified, not necessarily all. So in the spirit of Krzyzewski, I'd like to take an abstract mathematical approach to this question, and I'll apologize for a second time for this oversimplistic nature of the treatment. I'll just justify it to some extent through the classic mathematician's appeal that some of this simplification is done without loss of generality. But I hope that we can have a discussion later and you'll set me straight on some of the errors in my treatment. So I'd like to propose a perception communication model through which we can sort of investigate this, the notion of reality, or the question of ontology. Right, so I'm going to use, in mathematics, we call this graph theory. A graph is a network which is composed of vertices and edges, which can be assigned meaning. And the graph that we'll consider here will depict some sort of a universe, right, comprised of sentient beings or subjects and non-sentient objects. So there's several definitions I need to lay out here. So I'll define a m plus n dimensional system as a universe containing m subjects and n objects. In a simplistic sense, if you have, if m is 2 and n is 1, in a 2 subject, 1 object universe, this would be referred to as a 2 plus 1 dimensional system, the picture that you see on your left. So the follow-up definition would be, so now I have to define sort of operations within such universes. What are these subjects and objects capable of doing? And I will define the objects as things or events that do not interact with each other. The subjects can interact with the objects. Okay, this is what we'll think of as perception. And subjects can interact with other subjects, communication. Right? Now, ideally, I'm leaving out an important aspect of this. This should be a perception, cognition, communication model. But for sake of simplicity, I'm leaving out the cognitive element. Might be a big blunder, but we'll take our chances. Okay. Well, the next thing is, and here I approach this subject with trepidation, I will set up language for each of these systems. Okay. And language I will define as a set of symbols. Okay, this is a static model, so it's not being defined in the sense, time-binding sense that general semanticists typically define it as. So this is I'll define language in quotes as a collection of symbols, but more so as a union of 2 subsets. The first subset would be a set of symbols of perception, okay, that we use to perceive things and how we label them. And the second set would be the symbols of communication. Okay, these are the terms that we use for the operation between the S's. So in the picture that we have here, I have to move something around. The symbols of the set LP would contain A and B. The set LCOM would contain C and D. Okay, so once the set is defined, I can now examine the complexity of language or complexity of the universes that I'm talking about. So I define this, try to investigate the complexity using this index that I call the sanity index. And a sanity index is a consistency code for the language, which examines if perceptions and communication labels across any pair of subject-object or subject-subject are the same or different. Now, if they happen to be the same, then we assign the value 0 to it. If they happen to be different, then we'll assign the value 1 to it. So, so the code is essentially sort of a structural correspondence between language and perceived reality. Okay. So for any m plus n dimensional universe with n subjects and n objects, we have, and these are all mathematical curiosities. So these are, mathematicians don't leave things alone. You want to prove theorems and you want to examine things at their utmost generality, whether they have any consequence or not. Numbers are fun. So we can show that for any m plus n dimensional system, there are m squared n components for the label. So in a 2 plus 1 dimensional system, there are 4 digits in this label. So every universe, every system has this consistency code with, in a 2 plus 1 dimensional system, having four digits. And the way I define these digits are as follows. So the label corresponds to, so each of these digits can be a 0 or 1. So the first slot will tell you about the consistency between perceived symbols. Okay, so here, A and B, are they the same or not? The next 2 slots in the 2 plus 1 system will tell me about the consistency between the labels of perception and communication. So 2 and 3, there are 2 slots for that. And the final slot over here will tell me, okay, the consistency between the labels for communication. Now, so there are 4 digits and each can be a 0 or a 1. Okay, now it's again mathematically possible to show that, just give me a second, that in general for any m plus n system, there are this many unique universes. What I mean by unique is non-repeating and non-similar. Now you get a variety of possible combinations of these digits, and it tells you the number of possible universes that you could have, right? This number it's complicated to prove this, but in a 2 plus 1 system, it turns out there are 9 unique possibilities. And these are the 9 unique universes you could have, okay, which are not identical by simple reflection and things like that. Now, the interpretation of these possible universes, in universes, I should have said it in quotes, are quite interesting. So now each universe can be somehow related to some theory of reality that we've talked about. I wouldn't dare do this in this particular case because, like I said before, this is an oversimplified version, but I can make some correspondences. So for example, the 0000 case that you see on the top left, this could correspond to a universe, sort of the dogmatic or absolute reality universe. So there is no discrepancy between perception and communication. The 1111 can be taken to be the Vedantic or Maya or illusory universe, right? There is complete discrepancy. 0111 might represent a synesthetic or schizophrenic universe. The most interesting one perhaps would be the 1110 or 1010, the ones ending in 0, right? These are what I call personal universes, where the subjects perceive differently, but agree on the labels assigned to the objects. Okay. So no matter what one sees, the subjects use the same symbols to communicate. So just because 2 subjects refer to a certain shade of a color as blue does not imply that each subject or even both are actually perceiving the color as blue, or if at all they're perceiving anything. Okay. So certainly the map is not their territory. In fact, there may be no territory at all, right? So acceptance of the default perceived universe is based on the premise that its denial or criticism makes any logical discourse difficult or impossible. But while such an argument suffices for practical purposes, truth cannot be based upon convenience alone. And so this ontological question should continue to be explored. So I'll just end, well, as a physicist, I'm sort of instinctively drawn to these kinds of fundamental physical phenomena. But when something as simple as color itself is so riddled with complexities, what hope do we have to comprehend more complex aspects of perception and their interaction with language in general? It's a beautiful question. I guess there's no answer to it. At the end of this talk, I'm gonna go back to my own dogmatic sense of reality, absolute sense of reality, I suppose. But I'll end this talk with something sort of very articulated stated words in one of Corey Anton's own paper in 2015. He says, we cannot see the world as it is, we see the world as we are.